Hi, November 22nd, 2022. And this is problem 7, or the start of it, we'll see, of chapter 2, second 2. And we have to compute j of chi3, chi3, and its conjugate for two distinct values of q. I think we should try 4 as well. Why not? So the multiplicative group contains 1, t and t plus 1. And both of these guys are generators. T squared is t plus 1, and t times t plus 1 must then give unity. And we define chi. So this one maps to omega, and this one to omega squared. And 1 minus the x value, naught t plus 1 ups, and t, so chi of 1 minus x gives naught omega squared omega, so j of chi with chi gives naught plus unity equals 2, and that equals square root q. We know that the absolute, or the modulus of j, will be equal to the square root of q. So that's why I'm checking that. Next comes q equals 7. So our x values are 1, 2, 3, 4, 5, 6. And we need to find a generator. And I think 3 is a generator. So we take 3 to nth, 3, 9, 6, 18 minus 14, that's 4. Excellent. I think we are home. 12, that's 5. 15, unity. Excellent. And our values, we have 6 roots on the unit circle. Here we have omega, minus omega to the second, and minus omega, unity, and minus unity. 1, 2, 3, 4, 5, 6. Right. So, why did I write that here? Well, the generator was 3, which we chose the generator 3, so this maps to omega, or we could choose this. We should choose a generator, and there are 2 generators, minus omega and minus omega square. So let's take minus omega. Its square is omega squared. 6, the cube is minus unity. That makes sense. Minus 1 maps to minus 1. And 4 maps to omega. The product of these two. This guy, we have to multiply by minus omega every time. So 4, then 5, that's minus omega squared. And finally we get 1 omega to the third. Right. And then 1 minus x naught 6, 5, 4, 3, and no. Oh yes, 2, because naught would map to unity. All right. So minus omega squared plus omega squared plus omega squared plus omega squared minus omega squared. 1, 2, 3 minus 1. So we get omega squared. That was not very nice. I had expected it to have modular square root 7. How can that be? This is not the conjugate. It's not auto-conjugate, because the other one goes the other way around. Well, let's do 13, and will I try to do it by hand? The point is that we have a multiplicative group of order 12, and that means we have to have 12 here we have 6, so we have to have those in between. So obviously 1, 2, 3, 4, 5, 6. Yeah. So we need, this is of course, we have to have these 3 as well. And then we are missing 1, 2, 3. I wonder what that should be. That's 1/12, 5/12. Oh, here 5/12, yeah, and 7/12. This is not a good drawing. So they are not so easy to handle, those two. And then 11/12. So there are 4 we are missing. and they are not nice. Well, then let's try to do it by hand, and then instead of having the complex number, we put up the modulo of the argument of the map of the of chi of the element, and then we can just add those guys. So that's how I'll do it. So we need to find a generator of the multiplicative group. I will use Maple for that. I had turned it on so that we could use it. Six, no, two. Ah, it's dead. Sometimes I do something that kills it, and we can do nothing. Let's see if I can find it. This doesn't even work. That's amazing. Well, Maple had frozen, so I had to reboot the computer. I think we should let Maple find the generator instead of me doing it. And then instead of when it finds a primitive, then it just prints it. So 2 is actually a primitive element. That's nice. So am I able to do that by hand? 2, 4, 8, 3, 6, 12, 24, that's 10, 20, minus 13, that's 7. 24 minus 20 minus 13, that should give 11, shouldn't it? Minus 1, that gives minus 2, that's logical, but 12 times 2, that's 24, minus 13, that's 11. Oh yeah, it's 11. 11 times 2 is 22. That's minus 4. That's 9. 18 equals 5. 10 20 equals 17. 14 equals unity. Excellent. And then this primitive element, actually we have a lot, but no, we only have 2. So it must be to a point on the unit circle of order 3. So it's omega or omega squared. That's what I meant. Made wrong up here, of course. So we'll just have to correct that before I move on. Now, our generator is 3, so that maps to omega. 2 to omega squared, 6 to unity, 4 to omega, 5 to omega squared, and 1 to unity. 6 to unity, 5 to omega squared, omega, omega, omega squared. So, omega squared plus 1, that's not so good that I did that really. Plus 1 plus omega squared plus 1 plus omega squared. So it's 2 plus 3 omega squared. That's amazing. Omega squared is minus 1/2 minus square root 3i halves. So 3 times that plus 2, that's 3 halves. So it gives 1/2 minus 3 square root 3 halves. And then the modular of this number so it's 1 plus 27, it's 28/4, so that's exactly 7. So now we get a result that I can accept, that is approved. I got a little nervous when I saw this expression, but it did turn out right. Now, and of course the other guy, everything is conjugate, so it would just be plus here instead of, so I don't want to do that. Now, the generator is 2, maps to omega. Omega squared, unity, that's cube. And 1 minus x, that's minus 1. 12. 1 minus 4, it's 10. No, minus 7, that's 6. Minus 2, minus 5, minus 11, minus 10, minus 8, 9, minus 9, minus 6, naught, (12) maps to unity, 10 to omega, 1, that was 8, no, 6 maps to omega squared, 11 to omega, 8 to unity, 2 to omega, and 3, 5 to unity, 9 to omega squared, 4 to omega squared, 7 to omega squared, and naught to naught. Omega plus, that's not good, omega plus unity one, 2 plus 1, 2, 3 omega, 1, 2, 3, 4, 5, 6 omega squared. That equals 9 halves, no, minus 9 halves, plus 4, that's minus 5 halves. And up here we have 3 square root 3i divided by 2, and then minus 6, so that's minus 3 square root through imaginary unit halves. So let's do it like that. And the norm, or modulo, is 25 plus 27 fourth, 52 fourth equals 13. So I believe in my result. Well, that was that. Actually, I believe this exercise was more meant for people who hadn't made examples themselves while studying the section. But, well, here you are.